Part 2 of your Understanding Linear Functions review, questions 8 through 10. So starting on question 8, Alexa's produce stand sells roasted peanuts for $5.99 per pound. She says that she can model the cost with a linear function. Explain whether or not Alexa is correct. Well, let's look at the information that we have. Alexa's produce stand sells roasted peanuts for $5.99 per pound. To me, that sounds like a rate. A rate. So we've worked a lot with initial value and rate of change, and we had that template that we worked on for a while. Y equals your rate of change, y equals your initial value plus your rate of change times x. Well, what you have to keep in mind is to represent a linear function, we can also use y equals your rate of change times x. You don't have to write in an initial value here if there isn't one. And maybe I should rephrase that. There is one, it's just not visible. So if you don't buy any peanuts, you don't pay anything. So the initial value is, it's there, it's just you don't feel it. Okay, your initial value is $0. Now, if you decide to actually buy some peanuts and you buy a pound, let me finish that off, initial, well, then it's going to be $5.99 per pound. So your rate, or your rate of change, ROC, will be $5.99 per pound, right? Sorry, my writing's not great on here. So if we go to our regular template, which is very similar to y equals mx, it would be something like this. Y equals 0, because that's our initial value, plus, plus $5.99 x, 5.99x. However, that's extra. We don't need all that. You don't need that 0 there. So it's just going to be y equals 5.99x. And what you should realize is that this is, in fact, a linear function because it fits the form that we talked about in class for being a linear function. Okay? If you don't believe me, once again, you can create an XY chart. You can plug in a few values for x. And you'll notice the rate of change, it never changes. So if you were to graph this, you would see a straight line. Okay, that means it's linear. So, explain whether or not Alexa is correct. The answer is Alexa is correct. She can represent the linear function as y equals $5.99 times x. X represents the number of pounds of peanuts. On to number 9. A zucchini plant in Darnell's garden was 12 centimeters tall when it was first planted. Sorry about that. Since then, it has grown approximately 0.5 centimeters per day. Oh my goodness, this is bugging the heck out of me, guys. Since then, it has grown approximately 0.5 centimeters per day. Per day sounds like a rate. Write a rule to describe the function. That's the same thing as asking, express this as a linear function. So, once again, our initial value is 12 centimeters. So I'm going to put that in here for you guys. Initial value is 12. And of course, our rate of change, you can see it right here, is 0.5. So let's go back to our template, which I have written here on the side in case you've forgotten. So y equals, well, we usually do the initial value first. You guys are used to that. So initial value plus our rate, which is 0.5, times x. X represents the number of days since it was first planted. Okay? This is a linear function that represents the growth of Darnell's zucchini plant. So then, after how many days will the zucchini plant be 18.5 centimeters tall? Well, there's an easier way to do it, but if you want to play it safe, just add 0.5 to 12 as many times as you need to until you get to 18.5. And you can figure out what x is equal to. However, if you want to be fancy, after blank days will the zucchini be 18.5 centimeters tall? Well, x represents days, and y represents the total height of his zucchini plant. So if you know the zucchini plant is going to be 18.5 centimeters tall, you can plug that in place of y here, and you can put down the rest of the equation that we already had. And then you can just solve this linear equation for x, and it will tell you how many days it's going to take. So the first step will be subtract 12 from both sides. You're left with 6.5 equals 0.5 x. And to get the x by itself, you would divide by 1/2 or divide by 0.5. And what you're going to find then is that x equals 13. And in this case, it says after how many days? It's 13 days. You should be able to check that. Go back up. Starts at 12. You should count. Add 0.5 plus 0.5 plus 0.5 plus 0.5. You do it 13 times, and it should get you to 18.5. All right, on to the last one here, number 10. Vincent spent $45 to start up a lemonade stand. His lemonade business is doing well, so he decides to put money into his piggy bank each month and will not take any out. The situation is shown in the graph above. Actually, it's beside. As you can see, it's right here on the side. A says determine the rate of change, then explain what it means in this context. Folks, in order to figure out the rate of change when you're looking at a graph, take 2 points, and remember, we need to calculate the change in y divided by the change in x, or excuse me, the vertical change divided by, so the vert change, divided by the horizontal change. Okay? Very simply, I've done that for you here. I chose these 2 points. I said my vertical change was 5, 10, 15, 20, 25, and it should be $25 because that is the units on the y-axis. And then my horizontal change was from 0 months over to 1 month, so I only moved 1 month. So the rate of change is $25 per month. And to explain what it means in this context, well, I pretty much just did. It means Vincent is earning $25 per month. That would be your answer. B says determine the initial value and explain what it means. The initial value is all the way down here, folks. All the way down here. He borrowed $45, so he's actually in debt $45. The initial value is negative 45. And I just told you what that means. Explain what it means. The initial value means that Vinny, or Vincent, borrowed $45 to start his business. So when he began, he owed $45. Several months in, he had started to make a profit. Lastly, construct a function to model this relationship. Well, we know our initial value is 45. So y equals our initial value plus our rate of change. In this case, it's just $25. So 25 times x. And this function represents our linear relationship because he's gaining $25 per month. All right, folks, there you have it.